Alright, this guy I've shown before. One of the first sliders, wireless setups I made for charging. 2N4401 silicon transistor in there. I'm not really sure the resistor or capacitor. It's probably in another video. You can see what that looks like. That don't work good for charging these meters because the meter batteries in there are so crappy. They'll just pump that voltage up no problem. That doesn't really charge them all the way, but it charges them enough where I don't ever have to change these batteries out. I can continually use it, and it'll be a while before that low battery light comes back on. It won't be weeks, you know, but it'll be a good while. But it'll never come on if I just leave it there. So that's kind of like my never have to change my meter battery charger. I've got a few of these with coils on the inside to the battery, so that's why I can just set them there. This one right here is a little different. I wanted to show that because it seemed much simpler, and it's basically same deal. Smaller diameter coil, 30 gauge magnet wire, about 18 turns, I want to say bifilar, and I've just got a brown, silver brown 180 ohm resistor on my base there. And I first thought this thing wasn't doing anything because it started to get so hot. Over time I figured it was just basically just running straight DC through there, so to speak. And I realized it actually works pretty good. While it gets warm, the wire gets kind of hot. It gets hot. It's actually kind of hot to touch. It's not dangerous. I've left it in here for a while. It's no problem. It just puts a little warmth on the top of this box. But it'll charge this pretty healthy 9-volt Duracell cell pretty good because I can run it down to nearly dead and it'll bring it up no higher than about 9.5 volts. It's a pretty perfect marriage there. And I left this sit for about a 24-hour period. It wasn't trying to push over 9.5, but it will bring it up to that level from nearly dead overnight, which is pretty cool. And I know this thing doesn't put out plasma like that unless it's got decent charge in there. So I know this is not some superficial charge, otherwise this little plasma jet that's burning my fingers here would not be reaching out like that because it would just pull the cell down too rapidly. So yeah, I have pretty consistent usage with this guy. I was usually kind of turned off in the past about using 9 volts on these exciters because while it drives them good, they don't last long, and no one likes to buy and replace 9 volts. And I got tired of taking them out and charging them and all this and that. Now I can just throw it on there and not think about it. Boom. So I like that. Likewise, you can kind of see with this setup. Whereas, let's see, this other one is actually plugged in right now. So you can see with this one, I get a little light. I have a couple coils right here. This is your primary lower ohm. This is your higher ohm secondary, if you want to call it that. They're both wrapped around this air core. You can see the neon doesn't want to light, but this guy will light up a little bit. Actually, do much better on a different coil. When I put on this guy lights up fairly well, but the neon also comes on, which is pretty cool. So those both light at the same time. Something about the frequency of this guy right here is causing it to do that, whereas the other one won't. But another little thing I was going to do is make a little, maybe like a Green Lantern ring light, really just a ring light that I can use for certain things. I plan on just having the ring part like this being a coil, as you can see. And I want to throw a little tiny lithium cell on there if I can find one with just a pretty small LED, and I have a little switch on there so I can use that for whatever. And when I charge it, I can just let it sit right there, and that will be charging the battery. So it's cool that you can wind such a small little coil like this with that few turns. You know, it's probably what I want to say less. That is less than 15 turns right there, but it still will receive enough energy to charge a battery. That's pretty cool. So yeah, boom. That's what I use this guy for. tip 42, or excuse me, a tip 31 transistor, 180 ohm resistor across the base. That's all that is. It seems to work out pretty good from USB input. So that's about as far as I would take that circuit, considering you can probably buy a good resonant wireless charging coupling circuit for around $10. But for throwing one together dirty like, this is a pretty good deal right here. Because all I need to do is I need some more diodes, wind a few more coils, but I feel like I'll be able to charge a lot of things with that, so long as they're 9 volts and less. Whereas this guy wasn't quite doing it. I could charge AA's and I could charge these 9 volts. For whatever reason, I could not charge 18650 cells like what might go in a vape or a flashlight. Just wasn't doing it. Charge these guys in AA's, but nothing really bigger than that. This guy seems to want to do it all. So while this could also charge my phone, it would probably take a good while. But for whatever reason, the 9 volt seems to work great. So yeah, I thought that was pretty cool.